class. Today I'm going to tell you about one of my favorite theorems in mathematics, the Pythagorean theorem. First, here's some background about how it came to be. Pythagoras lived in around 500 BC and was a Greek philosopher and religious leader. He migrated to Croton, where he founded a philosophical and religious school that attracted many followers. The most important discovery of his school was the fact that the diagonal of a square is not a rational multiple of its side, or the diagonal of a square is not a number that can be expressed as the ratio of two whole numbers. This proved the existence of irrational numbers. Remember, irrational numbers are any real number that cannot be expressed as a ratio of integers. Irrational numbers cannot be represented as terminating or repeating decimals. Anyway, this discovery disturbed the mathematicians of the time because they believed that all relations could be reduced to number relations, or all things are numbers. So this was kind of an accidental discovery that was far ahead of its time. This discovery led to the investigation of right triangles and generalizing their properties. So, the Pythagorean theorem, also known as Pythagoras' theorem, describes a relation in Euclidean geometry among the three sides of a right triangle. In other words, it states that the square of the hypotenuse, the side opposite of the right angle, is equal to the sum of the squares of the other two sides, more commonly known as a squared plus b squared equals c squared. It is important to note that c always must be the biggest side, which is the hypotenuse, and the triangle must be a right angle, otherwise this won't work. But that's okay, because right triangles are very common in the real world, like in ladders against buildings, building bridges, art, architecture, in nature, pyramids. Okay, so here's the hot question. Do you believe this and take it for what it is, or do you know that it's true? Can you prove it? After this short lesson, you will be able to prove the Pythagorean theorem. There are lots of different ways to prove it, but this way is my favorite. First, recall that a proof is evidence or argument establishing or helping to establish a fact or the truth of a statement. Okay, so the first thing we're going to do is we're going to draw a right triangle and label the sides A, B, and C. It's important to note that C always has to be across from the right angle, and it's the hypotenuse. Now we're going to clone them. So there's four of the same exact triangle, sides labeled A, B, and C. The next thing we're going to do is we're going to label the insides of the triangle, the different angles. It'll just make it easier for later. So we're going to call the one across from A alpha and across from B beta, and then just note that this side, this angle here is always 90 degrees. In all of the triangles, it's the same. So now we're going to take a look at what does alpha plus beta equal. Alpha plus beta plus 90 is equal to 180. The inside of the triangle, the angles all add up to 180. So, subtract 90 from both sides, and then you know that alpha plus beta is equal to 90. So you know that they are complementary angles. So now we're going to make them so that a straight line goes between them here, and we're going to create sort of square in the middle of these four triangles. Important to note that this angle here is 90 degrees. So we're going to take this one here, and all we're doing is flipping it and making it into a square in the middle. So then we're going to take this last one, and we're going to move that one over. So now we have a square in the middle here, a square with side C. So the area of the big square is equal to A plus B squared. A plus B times A plus B. Agree that that's equal to A plus B squared. So now we're going to calculate the area of the square, big square, in a different way. We're going to say that the area of each little triangle here is 1/2 A times B. And the area of this big little square inside of it is C squared. So we now have the area of the small pieces, 1/2 AB plus 1/2 AB plus 1/2 AB plus 1/2 AB plus C squared. So that's the area of the square in a different way. And so we're going to simplify it and say that that's equal to 2ab plus c squared. So now we have just solved for this area of this big square, and we came up with two equations for it. So we're going to set them equal to each other because this is talking about the same square. So a plus b squared equals 2ab plus c squared. So now we're going to factor that out, and we have that. And we notice that there's 2ab on both sides, so they cancel out.
And then we're left with a squared plus b squared is equal to c squared.
Now that we believe it and know it's true, let's use it in an example problem.
Okay, so here's our problem. Miss Brunage wants to put up a Frosty the Snowman decoration on her roof. Her roof is 12 feet from the ground and she has a ladder that is 13 feet tall. How far from her house should she place the ladder so that it rests perfectly on the roof? Okay, so let's just circle the numbers here. We have 12 feet, 13 feet, and that's all we have right now. So let's draw the picture here. And this is what I came up with. So here's the snowman decoration, of course. And then we have the house, and then her roof, 12 feet. And then the ladder is 13 feet. And we need to find this distance here. We don't know what that is. So let's just isolate that triangle over here. We have 12 feet, 13 feet, and we know that this is a right angle. And we're solving for this side over here. So, using what we learned, the Pythagorean theorem, where a squared plus b squared equals c squared, we're going to say that a is the distance from the ground to the roof. So a is this distance here, plus, let's call b this side. We don't know what that is. Plus the distance the ladder squared, which is the 13. So let's solve for b. A squared plus b squared equals c squared. 12 squared plus b squared equals 13 squared. When you square them out, 144 plus b squared equals 169. And then what I'm going to do is I'm going to subtract 144 from both sides and get b squared equals 25. So b squared is equal to 25. And that means, therefore, that b is equal to plus or minus the square root of 25. Which the square root of 25 is plus or minus 5, but for distances, we're going to say that we're taking the absolute value. So the absolute value of -5 and 5 is 5. So let's check to see if this is right. 12 squared plus 5 squared. Let's see if that's equal to 13 squared. So 12 squared is 144, plus 5 squared is 25, and that equals 169. Is the square root of 169 equal to 13? Looks familiar, but let's just check. 13 times 13, 39. Add it all up, and you get 169. And 169, 169, and there you go. So if we go back to our original picture here, what is this distance? It's 5 feet. So she should place it 5 feet. That distance should be 5 feet.
Thank you for watching. See you tomorrow in class, and don't forget to do your homework. Good night.